We're now going to talk about compound locus problems. Suppose you are given 2 points that are 7 inches apart. You are given points A and B, which are 7 inches apart. What is the locus of all points 5 inches from A and 3 inches from point B? So here's point A, and here is point B, and they are 7 inches apart. Which points are 5 inches from A and 3 inches from B? Well, to be 5 inches from A, it's a circle. Where? That's 5 inches. In particular, I'm looking at the line that goes to B. Remember, that's 7 inches. Well, that's 5. In fact, let's just draw this a little bit bigger. Okay, those distances are 5. Okay, now, the locus is also the points that are 3 inches from B. Well, remember, from A to B is 7. I've gone 5, so this distance is just 2. But I want to go 3 inches from B. So it goes something like this, where these are all 3. And the locus is the ones that live up to both of these parts. They are 5 inches from A and 3 inches from B. This is the answer. These 2 points and only those 2 points. They are both 5 inches from A and 2 inches from B. Given that A and B are 7 inches apart. Okay. Find the locus that is 5 inches from a line and lie on a given circle. Well, here's the given line, L. So, the locus are points that are 5 inches from the line. It will be this line and this line, because it is given that these distances are in fact 5. Okay. But we're not done. We want the locus of points that are 5 inches from line L and lie on a circle. Well, we have a number of scenarios. The circle can go like that, touches those 2 points. It can be tangent to the circle. Shucks. It can be tangent, I meant to say is tangent to the line. This circle can be tangent to both lines. You can have a circle that's tangent to one line, but crosses the other line in 2 points. You can have a very big circle and it crosses line 1 and line 2 in 4 places. Or you can have a little circle that crosses nowhere. So the answers are, you can have no points of intersection. You can have 1 point of intersection. You can have 2 on one line. Or you can have 2 points, 1 on each line. You can have 4 points, 2 on each line. Or you can have 2 on one line and 1 on the other line. There's a number of cases here. The bottom line is you can have 0 points, 1 point, 2 points, 3 points, or 4 points for the locus. Let's try a couple more. The locus of points try that again. Oops. The locus of points that lie the locus, I don't know how to spell lie. The locus of points on y equals 7. The locus of points on y equals 7 and on the circle x squared plus y squared is equal to r squared. Okay. So you don't know what r is. Well, here's the line y equals 7. Now, you have a couple of scenarios. Remember, the center of the circle was at the origin. From the origin to here is 7. So you can have a circle of exactly radius 7, and the locus would just be that 1 point. You can have a circle of radius less than 7, and there is no locus. There is no point that lies on the line y equals 7 and the circle x squared plus y squared equals r squared. Or you can have the radius bigger than 7. In which case, you get 2 points. So either you get no points on the line and the circle, which was this case right here, or you get 1 point if r is 7. If r is bigger than 7, then you get 2 points. So it depends upon what r is. If r is less than 7, no points. If r equals 7, you get 1 point, which is at 0.7. If r is bigger than 7, you get 2 points. Let's do a couple more. Find the locus of points that are 1 centimeters from a 4 centimeter long segment and 2 centimeters from the midpoint of the segment. Find the locus of points that are 1 meter from a 4 meter line, segment, and 2 centimeters from the midpoint of the line segment, and 2 centimeters from the midpoint of the line segment. Okay, so you are 1 meter from a 4 meter line segment. So here is the 4 meter line segment. Starts here, finishes here. And the locus of points must be 1 meter from the 4 meter line segment. So here, well, actually it's going to be a line segment itself. Okay. So there it is. Let me just draw this a little bit higher so it looks symmetrical to the one below. I am claiming that that distance is 1 meter and that that distance is 1 meter. 1 meter. Okay, and it must be 2 centimeters from the midpoint of the line segment. Well, here's the midpoint. Well, I know that this is 1 meter, so to go 2 meters, maybe I go here and here, or here and here. So the answer is those 4 points. Those 4 points. Now, we needed to be, so each of these distances have to be 2. Now, we need to be a little bit careful because it might have been the case that to go 2 meters, let's say here, this is 1 meter, this is a little more, this is a little bit more. Suppose that this is not even 2 meters yet. Suppose that's not even 2 meters. That is, maybe you have to go out here, but what does that mean? That the line segment doesn't go out there. Okay, so you just have to verify that the 2 meters will occur where the line actually, the red line is actually there. Now, how do I know this is going to be? Well, I was given that the whole given line is 4 centimeters. That means that from the center, from the midpoint, that's 2 meters. If I take my compass and I put the needle right at the center, I put my needle right at the center, the midpoint center, and I put the pencil at the end, and I draw my arc, I realize, oh yeah. This distance is 2 meters, and it's on this line. It's on that line. So yeah, these are the locus points, those 4. You got to make sure that it actually ended up. It might be that there are no points that are 2 inches from or 2 meters from that midpoint and also lie on the line above or below. In other words, I just want to hammer this in. If this is the given line, 4 meters, and this line is 1 meter apart, and this line is 1 meter apart. So this is 1 meter, and this is 1 meter. And here's the midpoint. It's the center points that are 55 meters. So let me just be clear, that's 4 meters. So the center points that are 55 meters from the midpoint and are 1 inch or 1 meter away from the given line. So line 1 and line 2, those are 1 inch away, 1 meter away. The problem is that that distance isn't even 55 meters. 55 meters from the midpoint is like that. That's 55 meters. This is 55 meters. They don't intersect the line segment. Now you may say, well, extend this line. Well, then there's one problem, one concern I have. This is the given line segment. Okay? What does it mean for this point? What's the distance between that point and the line L? I don't really know. Or the line segment L. Now, if L was actually a line, I can say, oh, it's 1 meter. But it's not a line. It's a line segment. It ended. I would say the distance is the shorter one, actually. So, there's a bit of concern there. Let's try one more. The locus of points that are equidistant from 2 parallel lines and lie on a third line. And lie on a third line. So here are the 2 parallel lines. Those are the 2 parallel lines. Now, which points are equidistant from these 2 parallel lines? And the answer is this line, that line. Okay. And remember, lines go forever. Now you have a few scenarios. If the third line is not parallel to line 1 and 2, you get that is the answer. This point is equidistant from the two parallel lines, and it lies on this third line. That's the third line. Now, case number 2. The third line is parallel to line 1 and 2. But it's not line L. It's not that line L. It can be line 1, it can be line 2, it can be any other line parallel. Here we have no points of intersection. This is the third line. The next scenario is that this third line is that line. So the answer would be all the points on this line. All the points on this line lie on this third line, and they're equidistant from line 1 and 2. Every point on this line lies on that line, and they're equidistant from line 1 and line 2. So either you have no points of intersection, one, or infinitely many. This completes the section on compound locus, where you have 2 or more conditions to satisfy to get the locus points.